Okay, so clustering, right? Clustering, inferring levels and unlabeled data. Okay, the classification regression illustrations we just looked at are examples of supervised learning. Right? When I'm doing regression pani heऱ्यौं हैन अनि हामीले चाहिँ classification and regression both, right? As we saw, right? Classification भनेपछि के भयो हाम्रो लेभल्सहरु क्लासिफिकेसनमा के हुन्छ याद छ
डिस्क्रिट आउटपुटको लागि चाहिँ क्लासिफिकेसन कन्टिन्युअसको लागि रिग्रेसन छ
that's correct right? So now अब यो चाहिँ अब यसमा के हुन्छ भने in which direction यो unsupervised next type of learning यो चाहिँ supervised भयो जुन कि we looked at supervised last time, right? अब आज चाहिँ हामी we'll look at unsupervised. Okay? Unsupervised means के हुन्छ भन्दाखेरि त्यसमा चाहिँ we do not give any levels. I mean training गर्दाखेरि level दिँदैनौं, right? So unsupervised learning involves models that describe the data without reference to any known levels. I mean levels दिँदैनौं, right? Without the levels, it has to figure out, right? The relationship or the underlying insights, right? Okay. So one common case of unsupervised learning is clustering, in which data is automatically assigned to some number of discrete groups. Okay? So for example, we might have two-dimensional data like this. You have data, okay? Data, input data, there's no level at all. Right? So there's no level. The group right? And by I, it is clear that each of these points is part of a distinct group, right? Obviously, they're like this. You can see, your two-dimensional you're a group, so you are group, so you basically charter groups, right? Charter clusters, right? Okay, given this input, a clustering model will use the intrinsic structure of the data to determine which points are related. Okay? This is a very fast intuitive k-means algorithm. But algorithm just k-means algorithm, which we'll cover later. Something like this. See, very neat, very neatly. I mean, you can see the cluster. The algorithm figure out. The algorithm your data your math data. And I'm your data the algorithm clustering cluster there. So it's 4 clusters, right? Simple algorithm two-dimensional map, three-dimensional 3-dimension visualize so 3-dimension, 4-dimension, right? Especially 3-dimensional mathy. There's no way we can visualize, and there's no way we can find the groups, right? Find the clusters on our own. Right? So that's where these clustering algorithms, right? They come handy. They come in handy. So clustering algorithms, the k-means fits a model consisting of k cluster centers. Optimal centers are assumed to be those that minimize the distance of each point from its assigned center. So we'll look at this later, and it's in your we'll go through this. I haven't actually got some. Don't worry. Then circle might say on site. Okay, thank you. Okay, so now, all right. So this thing about clustering, which we'll look at later. Introduction, right? Qualitative, I guess qualitative description of you. Okay.
क्लस्टरिङ एल्गोरिदमहरु सेपरेट हुन्छ होला क्लस्टरिङ एल्गोरिदमले चाहिँ क्लस्टरमा छुटाइदिन्छ होला अनि के मिन्सले चाहिँ त्यसलाई लेभल लगाइदिन्छ हैन सर
के मिन्स आफैमा क्लस्टरिङ एल्गोरिदम के मिन्स भनेको एल्गोरिदम आफैमा क्लस्टरिङ इट्स अ क्लस्टर
ए मिन्सले पनि क्लस्टरमा डाटाहरुलाई चाहिँ सेपरेट गर्दिन्छ सर
यो अल्गोरिदमको नाम नै के मिन्स हो कि र यसको यो एक्चुअल यसको डिटेल्समा डिटेलमा पछि हेर्छौँ है एक्चुअली यो कसरी काम गर्छ विल एक्चुअली सी दिस है सो के मिन्स आफैमा चाहिँ इट्स अ क्लस्टरिङ है
भनेपछि के मिन्स चाहिँ क्लस्टरिङको एउटा अल्गोरिदम भयो हैन सर
there are many
अरु अल्गोरिदम नि छ उसको लागि
yeah that's right के मिन्स चाहिँ एउटा yeah so algorithmहरु धेरै छ algorithm त सयौं छ नि है alright so के मिन्स एकदमै simple है र एकदमै powerful algorithm चाहिँ के मिन्स is very nice algorithm right? Which we'll look at anyway. All right, so this might seem like a trivial exercise in 2 dimensions, but as our data becomes larger and more complex, such clustering algorithms can be employed to extract useful information from the data set. Right? Okay, अब अर्को खालको algorithm के छ भने unsupervised algorithm चाहिँ dimensionality reduction. Right? We have already used that. And I'm using it. ISMAP user, right? So dimensionality reduction is another example of an unsupervised algorithm in which labels or other information are inferred from the structure of the data itself. Right? We don't give the label. I mean, label right? The algorithm label rather it has to figure out. It has to the whole data lower dimension space. While retaining most of the information. So dimensionality reduction is a bit more abstract than the examples we looked at before. But generally, it seeks to pull out some low dimensional representation of data that in some way preserves relevant qualities of the full data set, means minimum information loss. Right? Determination. So different dimensionality technique routines measure those relevant qualities in different ways. Say manifold learning. So actually, obviously, last time I mean, 64 dimensional, digit 64 dimensional here. Then I'm 2 dimensional plot. So that is dimensional reduction. Okay? Let's see this. So if you look at this visually, a case. An example, consider the data shown in the following figure. See your figure managing. So we have this, this kind of data. Visually, it is clear that there is some structure in this data. It is drawn from a one-dimensional line that is arranged in a spiral within this 2-dimensional space. Okay? So in a sense, you could say that this data is intrinsically only one dimension. Right? So this one-dimensional data is embedded in a high-dimensional space. Right? So we'll study this. I just saw your orco subspace so which we'll see in detail anyway, right? So a suitable dimensional reduction model in this case would be sensitive to nonlinear embedded structure and we'll be able to pull out this lower dimensional representation. Right? So yes, my 2-dimensional data. So you can get a 1-dimensional representation from this. It's 1-dimensional. It's a 2 dimensions, right? Let's say 1-dimensional right? The following figures, the 1-dimensional was maybe a city, right? A city. So basically, your isco values or city is main code, right? It's main code. When you see, it's what counts again. You see, your 2-dimensional representation, 1-dimensional representation, the latent variable, right? Okay, so basically, okay, so summarize we have 2 kinds of algorithms. There are supervised algorithms, plus supervised machine learning, or unsupervised machine learning. Right? Supervised beneficy, this can predict levels based on level training data. Training data means level of right? Level, right? Target, right? This one, these are classification. Just making discrete categories or levels in discrete categories or this regression, continuous levels. We saw that. Right? This is unsupervised, mainly The on level data, we don't give the level data in the clustering and human scenario reduction. We'll study this in detail anyway. I have detail here. Mainly unsupervised learning is to be the supervised learning, the useful time, the powerful stuff. Unsupervised learning so give some supervised learning training data by hand by hand resources and it's error prone the resources so we ideally is unsupervised learning fully unsupervised learning but model train that's the best data level data and companies are we lack data, the machine learning model and training data. They have the data now. They mean that they do not have level training data, level data sign. Level data level around like machine learning self-supervised learning this one is right self-supervised learning level data this is about a machine they learn and baki data like level right Facebook self-supervised learning Jan LeCun he is a professor at NYU and he is one of the Turing Award winners 2020 Turing Award computer science Nobel Prize so when you're listening to self-supervised learning right so it's ultimately saying supervised learning as your
name actually ferry sir
Jan LeCun YANN LECUN Jan LeCun
YANN
as YANN LEC and Jan LeCun last year they won this Turing Award Jan LeCun, Jeffrey Hinton, and Yoshio Bengio, which is University of Toronto, University of Montreal. By the way, Jan LeCun Facebook AI chief. Anyway.
Okay.
Okay. Anyway, so you say qualitative analysis. Actually about quantitative analysis. Right? So this school resources. I think I have already sent you that. Otherwise, okay. But it's my case or a GitHub set. So GitHub Solon as the or GitHub saying GitHub. If you want to be it's all yeah,
त्यहाँ भएको कोडहरु यता कोल्याबमा रन गरेर क्लोन गरेर चाहिँ
ओके त्यसमा अलिकति अझै फ्यामिलियराइज अझै त्यसलाई एक्चुअली हैन अलिकति मजाले चलाउनु किनभने आजकल गिटहब सबै कुरा गिटमै हुन्छ गिटहबै युज नगरे पनि गिट युज सो यो द भर्जन कन्ट्रोल सिस्टम सो हामी सबै जो पनि कम्प्युटर टेक्निकल फिल्डमा हुन्छ आइटी फिल्डमा mostly we need to get up to change as a data scientist any kind of software I think that has become the standard anyway so let me see right so the GitHub rep clone so I'm gonna start from there right? So Marianne is it's right here right? So I'm going to start with chapter 5. By the way, kitab mani pad padhaya data science को त्यो GitHub हुन्छ है म तपाईहरुलाई त्यो लिंक पछि दिन्छु Okay, anyway, so let's start from this one. This machine learning यो मैले कभर गरेको यो हो अब हामी scikit-learn है we'll start here okay. So what I'm going to do is I need let me start my Python notebook. So what I'm going to do is open this. By the way, your notes are something it's very excellent notes. So it's not just it's एकदमै detailed form मा यहाँ छ मैले चाहिँ नोटहरु बनाएको छु हैन अझै डिटेल मा जानुहुन्छ भने it's all here है numpy pandas को सबै है all right so let's start with worker cover start with scikit-learn है अब यो machine learning गर्नको लागि अब हुन्छ there are many libraries हैन तर this एकदमै चल्ने भनेको चाहिँ एकदमै हैन राम्रो एकदमै useful library scikit-learn scikit-learn extremely powerful and useful okay? So I'm gonna let's get introduced to scikit-learn okay? So you just say numpy pandas is the Oracle library okay? Pandas library okay? So there are several Python libraries which provide solid implementation a range of machine learning algorithms. Okay? One of the best known is Scikit-learn. Scikit-learn is one of the best known. Okay? So it's every data scientist, machine learning engineer has to learn right? Scikit-learn. Okay? So okay, it's a package that provides efficient versions of large number of common algorithms. Scikit-learn is characterized by clean, uniform, and streamlined API, right? Which you will see, right? As well as by very useful and complete online documentation making analysis tool. Okay. A benefit of this uniformity is that once you understand the basic use and syntax of Scikit-learn, one type of model switching to a new model algorithm is very straightforward. When एउटा model run गर्न सक्नुभयो भने you can pretty much run any algorithm. I mean, these are uniform, right? Pretty much you do the same thing with the other one, other algorithms. Okay, so the section provides an overview of Scikit-learn API. Okay? A solid understanding of these APIs will form the foundation for understanding deeper practical discussion of machine learning algorithms and approaches. So let's see. Let's start by covering data representation. Right? Scikit-learn with data representation, and then we will look at estimated API, and finally go through more interesting examples. Right? Okay, let's see. So data representation in Scikit-learn. Okay? Machine learning is about creating models from data, which I explained last time. For that region, we'll start by discussing how data can be represented and understood, and in order to be understood by the computer. Okay? So best way is table of data. Table. Okay? Scikit-learn table of data. Okay? So data is table. A basic table is a two-dimensional grid of data in which rows represent individual elements of the data set and columns represent quantities related to those elements. Okay? So you have already seen this, right? This month, iris data set, iris data set, famously analyzed by Ronald Fisher in 1936. Okay? 1936. Okay? we can download this data set of you. I mean, you go to let me run this anyway. Okay, so I'm going to run it. So here it is. Understand? So it's an iris. It's an iris file. You guys know this, right? Sepal length, sepal width, petal length, petal width. See, species. It's a label. This is the label, right? Okay. Here, each row of data refers to a single observed flower, and the number of rows is the total number of flowers in the data set. In general, we'll refer to the rows in matrix as samples, and the number of rows of the matrix as samples, and number of rows as n samples. Right? Whenever see, it's like you say sample, you're a sample. So this is one sample. Example, example of a sample. Okay, let me take a sleep and add a little bit deeper in it. Let me illustrate this. Okay. So it's missing. Right. This man, so now each is iris data set how many rows? Rows are how many rows are there?
150 हो कि जस्तो लाग्छ सर.
Yeah, right. Okay. So harek row harek row is it's an example.
Sample sir.
Example पनि भन्छ अनि what is it? Samples, right? हरेक चाहिँ sample, right? Example or sample, right? Sample. भनेपछि यसमा पनि 150 samples. Sample. अनि यसको अब n sample यो कतिवटा sample छ त्यसलाई चाहिँ हामी के भन्छ n underscore sample, है? भनेपछि iris data को n underscore sample कति भयो? n samples कति भयो?
150 सर.
Right. N samples. Right. All right. So now, likewise, each column of the data refers to a particular quantitative piece of information that describes each sample. In general, we refer to the columns of matrix as features and the number of columns as n features. You see, our use and feature, feature, our level of feature. Your use and it be your jolly say the quantitative description. Right? Is called separating your quantitative description of each sample. Each sample for quantitative description. These are called features. When you have got features for here, how many features we got?
Features.
Yeah, that's right. Simple. Yes, it's our features. Right? And in this go number, right? N features. Right? N features got you this way. Number of features is equal to
4 होने वाला है, इसको 4.
N features 4 by, right? So n underscore features. Okay, so yes, what Mary? Okay, let's talk about feature matrix. Okay, features matrix. This table layout makes clear that the information can be thought of as two-dimensional numerical array or matrix, your matrix, right? Which we call feature matrix. U matrix and Q. This is called the feature matrix or U matrix and matrix rows and columns. Your two-dimensional array, two-dimensional array. So it's a matrix, right? 2D matrix. Your matrix को नाम यसलाई चाहिँ के भन्छौं? Feature matrix. है? नाम के भन्छौं? Features matrix. It's a matrix. Right? By convention, this features matrix is often stored in a variable named x. So normally, के मा राख्छौं? X भन्ने एउटा variable, capital X, by the way. है? You see? Capital X. Right? Capital X. The feature matrix is assumed to be two-dimensional, with shape n samples by n features. When you see, okay. So when you see, इसको shape के हुन्छ त? your feature matrix shape here in terms of your n sample n features, right? You data in terms of these two, right? It's called shape के भन्छ
n samples, n features.
right? N samples by n features. Okay, very good, very good, right? So n samples by n features, right? Okay, very good, right? All right, so n is most often done in a numpy array or pandas data frame. Normally, right? And it's often contained in a numpy array. Your sample, your array numpy array amounts that are mostly data frame, right? Because two-dimensional, let's say it's called the natural representation mouse, data frame mouse, right? Okay, we have learned a lot about data frame length exported basically, right? Okay, all right, so okay, so the samples always refer to the individual objects. We saw that, right? Okay, you go ahead. Future you okay, let's talk about target array. Okay? Target array when I give them label or target array. Okay? So target array, which we normally call Y. It's using array. So here's the one-dimensional data. Understand? This one right here is a one-dimensional sample. Okay? Using your target. Let's say target array. Okay? The level also. You see? As it's an array most one-dimensional, so we can put it in an array. Right? Like target array. Right? And so your one-dimensional work see? Array simply numpy array ma राख्न सकिन्छ. बुझ्नुभयो? All right, so like normally हामी के ले represent गर्छौं भन्दाखेरि y, right? Y. यसलाई चाहिँ x, right? Feature matrix लाई x अनि target array लाई चाहिँ हामी y, right? Y ले represent normally. This y ले represent हुन्छ. Target array is usually one-dimensional. यो कतिवटा हुन्छ भन्दाखेरि of course यसमा कतिवटा हुन्छ? कतिवटा target array को length कति हुन्छ?
150
n samples. In general के भयो? N samples.
Yes, sir. Yes.
N samples. N samples. Okay. All right. So far, so good. Right. But this one, यो series पनि हुन सक्छ किनभने यो त one dimensional हो भनेपछि normally array हुन्छ तर कहिलेकाहीँ series पनि हुन सक्छ अनि series पनि one dimensional right? Okay. All right. The target array may have continuous numeric value of the various, of course, your target array numeric your के हुन्छ अब यो केसमा चाहिँ यसमा categorical छ categorical discrete छ है नभए continuous पनि हुन सक्छ यो है continuous. Okay. All right, so while some scikit-learn estimators to handle multiple target values in the form of two-dimensional target array, will primarily work in the common case models. So when it's कहिलेकाहीँ के हुन्छ भन्दाखेरि तपाईँको target चाहिँ it could be more than one column, right? यसमा जस्तै यसमा के हुन सक्छ भन्दाखेरि जस्तै one hot encoding हुन्छ है अनि पछि त्यसमा आउँछ है one hot encoding गर्दा त्यसमा तीनवटा जस्तै यहाँ तीनवटा स्पेसिस छ भने के हुन्छ भन्दाखेरि सो तीनवटा हामी यो चाहिँ कस्तो हुन्छ तीनवटा कलम हुन्छ कि तीनवटा कलम हुन्छ जुन कलमको त्यो फ्लावर हो नि त्यसमा 1 हुन्छ अरूमा 0 हुन्छ है सो त्यस्तो केसमा one dimensional भएन है त्यो केसमा चाहिँ के हुन्छ भन्दाखेरि त्यो चाहिँ two dimensional हुन्छ जसमा कि n samples र n targets हुन्छ है जस्तै यो केसमा चाहिँ तपाईको कति हुन सक्छ भन्दाखेरि 150/3 हो है अनि तीनवटा स्याम्पल तीनवटा लेभल्स छ नि त है सो त्यो चाहिँ हामी पछि आउँछ तर अहिले नर्मली हामी one dimensional मै जाउँ है पछि चाहिँ है we may have to deal with that later okay the one or two because if you we'll talk about that later one or two okay? All right often one point of confusion is how the target array differs from the it's called the distinguishing feature of target array they usually quantify differently. So okay, all right. So you're clear about all of this, right? Okay. So so far, okay. Let's recap. Right? So I'm ready. Now we know what a feature matrix is. And feature matrix when right? Target array when feature matrix, target array. And this we see and sample when what is a sample? So what is a sample?
Total number of examples.
Sample. For example, what is a sample or an example? And sample like sample. Sample
data collection but
so what is a sample? I mean, it's my sample. Which one is the sample keyword? You have a data frame saying it's a sample.
Sample भनेको number of rows हरु हुने भयो सर. एउटा रो भनेको एउटा sample हुने भयो सर हैन.
एउटा row भनेको एउटा sample. Yes. Hey, numbers for that हैन. Number त n underscore sample हैन. हैन? Okay. कुरा बुझ्नु भयो? Sample or n samples different thing. They are different things. You could have okay. N underscore sample saying yes, number of samples. But what is a sample? I know. What is a sample? Each row is a sample. I know. So okay. So it makes sense now, right? Okay. So each row give a sample. So yeah, yes, yeah, sample here.
And the
yes. This is 5 samples, right? And you see, total man, so you data set x plus or samples, n samples say x plus. Okay. This is about target array one. You see, here also, what is a target array? Which one is the target here?
The species when anything.
Species, right? Target array one is keyword.
हाम्रो फाइनल लेभल जस्तो भयो के सर त्यो
level to target array. What is target array? Target one, yeah, that's right. What is target array? Target array one is the feature matrix one is keyword.
And samples by n.
Yeah, and samples by n features, right? It's for shape. Sigari, we see my isma your data set. Target array को shape के भन्छ?
n samples n target हुने भयो सर.
n samples comma हुने भयो 150 comma.
किनभने यो त one dimensional हो नि. यहाँ दुईटा त हुने भयो नि. अनि यो त one dimensional हो नि त. हैन? So यो आफैमा यो target array छ one dimensional छ नि. This कति भयो?
n samples comma.
Right? And samples comma. And target and target two dimensional. Because you can socks at your case. Okay. So I hope it's clear. Right? Clear saying. Okay. So I would say let's do something here. Okay? With this target array in mind, can you see born? It's like visualization. And that's what is again. It's a pair plot, if you remember. You pair plot go so it's my keyboard. Obviously, same. Let's go correlation. Right? Correlation. So petal width to petal length correlation. Right? So basically, you the scatter plot. Right? Just like we have correlation extended, we can reduce correlation here. Okay? This is highly correlated. The petal length of petal width highly correlated. So always like say this positive, something of positive correlation in the hinge. Something of positive correlation makes pronounced the petal length of petal width एकदमै pronounced, एकदमै strong correlation देखिन्छ. अरूमा चाहिँ खासै देखिदैन. So this one तीनटा component है. तीनटा components. यसमा तीनटै componentमा there's you can see that a very strong relationship. यसमा चाहिँ यहाँनिर cytosama चाहिँ there's pretty much zero correlation. Right? यहाँनिर positive छ, right? So I mean अब यसमा चाहिँ अब it's this is the histogram, right? KDE plot of the cytosine मात्रै, हैन? This is versicolor and this is versioning. यो histogram है, अब ना KDE plot, right? Okay, so अब चाहिँ extract feature matrix and target array from the data frame, which you can do using some of pandas data frame. Right? अब यसमा के भयो भन्दाखेरि now हामीले अब यसलाई छुट्याउनु पर्छ है, यसलाई छुट्याउँ है। अब हामीले यो किन गरिरहेको छौँ भन्दाखेरि हामीले यो सबै हामी टर्मिनोलोजीमा हामी बिकज हामी गयौँ नि सुरुमा है, फिचर म्याट्रिक्स भने यो हो, टार्गेट एरे भने यो हो, यसको हैन डिमेन्सन्सहरु यस्तो हुन्छ, स्याम्पल्स भने यो हो हैन। त्यो किन गर्दैछौँ भन्दाखेरि हामीले चाहिँ हाम्रो डेटा यसरी तयार गर्नु पर्यो कि साइकिट लर्न जुन मोडलले जुन हैन टर्मिनोलोजी युज गर्छ हैन, अनि उले चाहिँ जुन फर्मेटमा डेटा उले एक्सपेक्ट गर्छ त्यो अनुसारको हामीले त्यो डेटा तयार गर्छ है, बुझ्नुभयो। सो त्यो कारणले गर्दाखेरि नाउ यो गर्नु पर्ने कारण थियो हैन, जस्तै फिचर म्याट्रिक्स बनाउनु पर्यो, टार्गेटहरु पर्यो हैन, त्यसको डिमेन्सन्सहरु मिल्नु पर्यो हैन। सो यो कुराहरु त्यसैको लागि that's what we're trying to get है त। So let's see, अब हामी के गर्छौँ भन्दाखेरि let's create feature matrix है, जुन आइरिस डेटा सेट छ नि, आइरिस डेटा सेटको फिचर म्याट्रिक्स बनाउँ है। अब तपाईले हेर्नुस् त्यसमा, सो यसको फिचर म्याट्रिक्स बनाउनु पर्दाखेरि के गर्नु पर्ला, यसको फिचर म्याट्रिक्स मात्रै चाहियो मलाई। यसमा दुईटै छ, फिचर म्याट्रिक्स पनि छ, टार्गेटहरु पनि छ। मलाई फिचर म्याट्रिक्स मात्रै चाहियो भने के गर्नु पर्यो मैले? What should I do?
ड्रप गरिदियो सर स्पेस।
Yes, that's right. यसलाई ड्रप गर्नु पर्यो नि त है, खाली हामीले यति मात्रै लिनु पर्यो है। त्यो आइरिस डेटा सेटबाट यो सबै आएको छ नि हैन, भनेपछि यसलाई फाल्नु पर्यो कि यसलाई फाल्यो भने त मेरो के आउँछ, हाम्रो के आउँछ, फिचर म्याट्रिक्स आउँछ है। सो लेट्स ट्राई टु डु दैट है। सो के गरौँ हेर्नुस् त, एक्स आइरिस अब एक्स भनेको हामीले अघि भनिहाल्यौँ हैन, फिचर म्याट्रिक्सको लागि हामी नर्मली के गर्छौँ, क्यापिटल एक्स मा राख्छौँ, एउटा कन्भेन्सन हो कि। सो इट्स अलवेज अ गुड आइडिया टु फलो कन्भेन्सन, कन्भेन्सन स्ट्यान्डर्ड फलो गर्यो भने चाहिँ सबैको काम सजिलो हुन्छ है। सो एक्स क्यापिटल एक्स अन्डरस्कोर आइरिस भनेर चाहिँ के भयो, फिचर म्याट्रिक्स। फिचर म्याट्रिक्समा हामी के गर्छौँ भन्दाखेरि जुन आइरिस डेटा सेट थियो, आइरिस भनेको यो होल थिङ, दिस होल थिङ इज आइरिस हैन। त्यसबाट के गर्छौँ, स्पेसिसलाई ड्रप गर्छौँ है, अनि कलम इक्वल टु सरी एक्स इज इक्वल टु 1 हैन, कलम ड्रप भयो है, स्पेसिस कलम ड्रप भयो भएन, यो ड्रप भयो नि, यो ड्रप भएपछि बाँकी के रह्यो हेर्नुस् त, एक्स आइरिस गर्दाखेरि अब फिचर म्याट्रिक्स आयो हेर्नुस् त, 150/4 को है कम्प्लिट फिचर म्याट्रिक्स आयो है। सो फर सो गुड, बुझ्नुभयो? ठिक छ, बुझ्नु भएको छ?
हजुर सर बुझिरहेको
है। ओके, अब त्यस्तै गरी आई वान्ट टार्गेट एरे। टार्गेट एरेको लागि के गर्नु थियो, यसै भयो हैन, आइरिस डेटा यो त आइरिस हो, टार्गेट एरे निकाल्नलाई के गर्नु,
ड्रप गरे हुन्छ सर।
खाली यो मात्रै लिए हैन, यो मात्रै लिए भइहाल्यो हैन, यति मात्रै लिए त पुगिहाल्यो हैन। ड्रप गर्नु भन्दा पनि यो किन ड्रप गर्नु पर्यो, यति हैन, यति सबसेट गरे भयो नि त हैन, यसलाई सबसेट गरे भने आइहाल्यो, यति लियो भने त र टार्गेट एरे आइहाल्यो हैन। सो के गर्ने भन्दाखेरि सिम्पली आइरिस हैन स्पेस गरेर के भन्छ, यो चाहिँ के हुन्छ, के फर्ममा आउँछ भन्नुस् त, वाइ अनि वाइ आइरिसको 150 मा आयो, 150 कमा भनेपछि 1 डिमेन्सनल भयो, 150 वटा छ है। भनेपछि यो यसको टाइप के भन्छ मलाई, यसको टाइप
सिरिज हुने सिरिज हुनेको अरे हुनेको कि सिरिज
हुन्छ कि अरे हुन्छ, सिरिज के हो, दुईटा मात्रै एउटा दुईटै त हुन सक्दैन है, के हो
अरे हुनुपर्छ, अरे हो
Array कसरी भयो डेटा फ्रेमबाट मैले यसरी गर्दा array आउँछ array त कसरी आउँछ
हेर्नै पर्यो सर अब
series and series correct answer that is the correct answer we series भन्नु भयो नि त हैन it's a series of course हैन so पहिला दिनुभएको जुन आन्सर थियो yeah that's correct series होइन किनभने कुनै पनि डेटा फ्रेमबाट हामीले एउटा मात्रै कलम लियो भने it's always a series है it's very simple जहिले पनि कुनै पनि डेटा फ्रेमबाट एउटा मात्रै तपाईले यसरी है यसरी तपाईले सबसेट गर्नुहुन्छ नि है एउटा मात्रै कलमलाई सबसेट गर्नुहुन्छ you always get a series back है यो कुरा याद गर्नु है बुझ्नुभयो यो कुरा बुझ्नुभयो मैले भनेको कुरा बुझ्नुभयो मैले भनेको कुरा बुझ्नुभयो है त्यो एकदम सजिलो छ के त्यति याद गरेपछि कुनै पनि डेटा फ्रेममा मैले डेटा फ्रेम गरेर यसरी एउटा कलमलाई मैले सबसेट गरे भने इट्स अलवेज वाट a series it's always a series है किनभने डेटा फ्रेम भनेकै सिरिजहरु जोडेर बनाएको के हैन यो एउटा सिरिज अनि यसको यो इन्डेक्स हुन्छ हैन यो सिरिज जोडेर एउटा डेटा फ्रेम बन्ने हो के हरेक कलम एउटा आफैमा सिरिज हो अनि हामीले यसबाट एउटा सिरिज दियो भने यो एउटा निकाल्यो भने त्यो सिरिज भन्छ है दुईटा सिरिज जोड्यो भने डेटा फ्रेम भन्छ
त्यो फिचर म्याट्रिक्स चाहिँ डेटा फ्रेममै हुनु भयो नि सर
अफ कोर्स है फिचर डेटा फ्रेम नै हुनु अर्को त हुनै सक्दैन सिरिज त हुन्छ सिरिज त 1 डाइमेन्सनल यता 2 डाइमेन्सन छ नि सो यो चाहिँ त यस दिस इज डेटा फ्रेम तर त्यो डेटा फ्रेमबाट एउटा मात्रै कलम निकाल्नुहुन्छ भने चाहिँ